Hey everyone, in this video we're going to be continuing to graph different types of polar equations. So the first type we're going to be graphing is a limacon, and there are a few different cases of a limacon. So your limacon form is a plus or minus b cosine of theta, or r equals a plus or minus b sine of theta. So here's our first one. R equals 2 plus 3 sine of theta. So we're going to make our little t-chart here. We'll start with 0. Sine of 0 is 0, and 0 plus 2 is 2. Pi over 6. So sine of pi over 6 is 1/2. 1/2 times 3 is 3/2. Plus 2 is going to be 7/2, or 3.5. So I should start graphing. Sorry about that. So here's 2. And then at pi over 6, we're at 3.5. So far we have this. Then we're at pi over 4. Sine of pi over 4 is root 2 over 2, times 3 is going to be 3 root 2 over 2, plus 2 is approximately 4.1. So somewhere in here. So far this is our kind of curve here. Then pi over 3, sine of pi over 3 is square root of 3 over 2, times 3 is 3 square root of 3 over 2, plus 2 gets you about 4.6. A little over the halfway mark there. Okay, and then at pi over 2, sine of pi over 2 is 1, times 3 is 3, plus 2 is 5. So pi over 2, 5. So there we have our half of our curve here. And then we'll just continue. So 2 pi over 3. Again, the sine of 2 pi over 3 is the same as pi over 3, which is root 3 over 2 times 3 plus 2 will get you 4.6. So we'll see some symmetry happening here. So we get 4.6. When we plug in 3 pi over 4, we're going to get out 4.1. When we plug in 5 pi over 6, we're going to get 3.5, which is right here. And then when we plug in pi, we're going to be back at 2. Okay, then things change a little bit. So keep doing our p-chart. So let's talk about 7 pi over 6. So the sine of 7 pi over 6 is negative 1/2, times 3 is negative 3/2, plus 2. That's going to get us 1/2, or 0.5. So 7 pi over 6, we're at 0.5, which is right here. Okay, and then at 5 pi over 4, sine of that is negative square root of 2 over 2, times 3 is negative 3 square root of 2 over 2, plus 2 gets us about negative 0.1. So remember, so we're going to go to that 7 pi over 4 spot, but negative 0.1 is going to be on the other side. So negative 0.1, somewhere in there. Okay, and then 4 pi over 3. Sine of that's negative square root of 3 over 2 times 3 plus 2 is going to get us about negative 0.6. So somewhere right in there. Okay, and then 3 pi over 2. Sine of 3 pi over 2 is negative 1, times 3 is negative 3, plus 2 is negative 1. So that'll put us right here. Okay, and then we're going to see some symmetry again. So at 5 pi over 3, sine of that is negative square root of 3 over 2 times 3 plus 2. It's going to give us negative 0.6. So somewhere around there. Then 7 pi over 4, when we plug that in, we'll get out negative 0.1. And then 11 pi over 6 is going to get us 0.5. So somewhere sorry, along there. And then back to 2 pi will get us 2. So that finishes off. So this is a limacon with an inner loop. So if your a over b is less than 1, notice our a is 2, our b is 3, that's less than 1, you're going to have a limacon with a loop. All right, number 2, we're going to see an example of what it looks like when a over b equals 1. So here's an example where a and b are the same value. So we're going to again make our t-chart here. So if we plug in 0, cosine of 0 is 1, times 2 is 2, plus 2 is 4. So 1, 2, 3, 4. Okay, pi over 6. So cosine of pi over 6 is square root of 3 over 2, times 2 is just square root of 3, plus 2 is about 3.7. So pi over 6, 3.7, somewhere around there. Okay. Then pi over 4, cosine of pi over 4 is square root of 2 over 2, times 2 is just the square root of 2, plus 2 is about 3.4. Okay, pi over 3, cosine of pi over 3 is 1/2, times 2 is 1, plus 2 is 3. Okay, pi over 2, cosine there is 0, times 2 is 0, plus 2 is 2. So I'll be right here. Okay. Then we have 2 pi over 3. Cosine of 2 pi over 3 is negative 1/2. Times 2 is negative 1, and 2 plus 1 is 1. So 2 pi over 3, we're going to be at 1. All right. Then 5, or sorry, blah, 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 excuse me. 3 pi over 4 is our next spot. So cosine of that's negative square root of 2 over 2, times 2 is negative square root of 2, plus 2 is going to be about 0.6. So 3 pi over 4, 0.6, so somewhere in there. Then we've got 5 pi over 6. Cosine of 5 pi over 6 is negative square root of 3 over 2, times 2 is negative square root of 3, plus 2 is about 0.3. So we're just kind of getting closer and closer in here. We're just kind of getting a lot of points there. And then at pi, cosine of pi is negative 1, times 2 is negative 2, plus 2 is 0. So it takes us right here to the middle. Then we're going to see a lot of symmetry. So I'll show you. So the next point is 7 pi over 6. So cosine of that is negative square root of 3 over 2, times 2 is just negative square root of 3, plus 2 is going to get us 0.3. So then we're going to start working our way out. So 0.3. I think I got that almost on the right line. Then 5 pi over 4. Cosine of that is negative square root of 2 over 2, times 2 is negative square root of 2, plus 2 is going to be 0.6. So again, we're just kind of curving out here. 4 pi over 3. Cosine of that is negative 1/2, times 2 is negative 1, plus 2 is positive 1. So 4 pi over 3, positive 1. Okay, 3 pi over 2, cosine of that is 0, and 0 plus 2 is 2. Okay, then we've got 5 pi over 3. Cosine of 5 pi over 3 is 1/2, times 2 is 1, and 1 plus 2 is 3. So now we're going to see, again, some symmetry from when we started. So when we plug in 7 pi over 4, we're going to get that 3.4. When we plug in 11 pi over 6, we're going to get that 3.7. And when we plug in 2 pi, we'll be back to 4. All right, so this shape right here is a cardioid. It's still a limacon, but the specific type is called a cardioid. It kind of looks like a heart. All right, next one, we've got r equals 3 plus 2 sine theta. So we're going to see what happens when our a over b is in between 1 and 2. So plug in 0, sine of 0 is 0, times 2 is 0, plus 3 is 3. So 1, 2, 3. Okay. Plug in pi over 6, sine of pi over 6 is 1/2, times 2 is 1, plus 3 is 4. So far we have this. Okay, then we're going to plug in pi over 4. Sine of pi over 4 is root 2 over 2, times 2 is root 2, plus 3 is approximately 4.4. Whoops, it's supposed to be about here. Erase that. Okay. Then pi over 3, sine of pi over 3 is root 3 over 2, times 2 is just root 3, plus 3 is approximately 4.7. Okay, and then at pi over 2, sine of pi over 2 is 1, times 2 is 2, plus 3 is 5. Okay, then plugging in 2 pi over 3, again, sine is 1/2, times 2 is 1. Whoops, sorry. Sine of 2 pi over 3 is not 1/2, it's square root of 3 over 2. Times 2 is square root of 3 plus 3. That's going to get us that 4.7. So we're going to see some symmetry. So we'll get 4.7. Plug in 3 pi over 4. You're going to get out 4.4. Plug in 5 pi over 6. You're going to get 4. Plug in pi. So sine of pi is 0. 0 times 2 is 0 plus 3. So 1, 2, 3. Okay, and then we'll see the rest of the graph here. So if we plug in 7 pi over 6, sine of 7 pi over 6 is negative 1/2, times 2 is negative 1, plus 3 is 2. So 7 pi over 6 is 2. Okay, 5 pi over 4, sine of that's negative square root of 2 over 2, times 2 is negative square root of 2, plus 3 is about 1.6. All right, then we're plugging in 4 pi over 3. Sine of 4 pi over 3 is negative square root of 2 over 2. Negative square root of 3 over 2 times 2 is negative square root of 3. Plus 3 is going to get us about 1.3. So next line over a little bit closer. At 3 pi over 2, sine of that is negative 1 times 2 is negative 2, plus 3 is 1. Okay, then plug in 5 pi over 3. Sine of 5 pi over 3 again is negative root 3 over 2 times 2 is negative root 3 plus 3 is going to get us that 1.3. So again, we're going to see some symmetry here. So if I plug in 7 pi over 4, I'm going to get out 1.6. If I plug in 11 pi over 6, I'm going to get 2. And if I plug in 2 pi, I'm going to get out 3. All right, so there's our shape. It kind of looks like a cardioid on its side, but we call this a dimpled limacon. All right, limacon number 4. So this time, a over b is greater than or equal to 2, and we're going to see what happens there. So if we plug in 0, cosine of 0 is 1, times 2 is 2, 4 minus 2 is 2. So 0, 2 is where we're going to start. Pi over 6, cosine of pi over 6 is square root of 0 over 2, times 2 is just square root of 3, and 4 minus square root of 3 is about 2.3. All right, pi over 4, cosine of pi over 4 is root 2 over 2, times 2 is just root 2, and 4 minus root 2 is about 2.6. So 2.6, somewhere in here. Okay, and then pi over 3, cosine of pi over 3 is 1/2 times 2 is 1, and 4 minus 1 is 3. Right, pi over 2, cosine of pi over 2 is 0, and 4 minus 0 is 4. Okay, if we plug in 2 pi over 3, cosine of 2 pi over 3 is negative 1/2 times 2 is negative 1, and 4 minus the negative 1 is positive 5. So at 2 pi over 3, we're at 5. Okay, and then 3 pi over 4, cosine of that's negative root 2 over 2, times negative 2 is just root 2, and 4 plus root 2 is about 5.4. Okay. At 5 pi over 6, cosine of 5 pi over 6 is negative square root of 3 over 2 times negative 2 is positive square root of 3, plus 4 is about 5.7. So a little bit farther out. And then at pi, cosine of pi is negative 1 times negative 2 is 2. 4 plus 2 is 6. All right, now we're going to finally get to see some symmetry. So if we plug in 7 pi over 6, cosine of 7 pi over 6 is negative square root of 3 over 2 times negative 2 is square root of 3 plus 4 is at 5.7. So that'll be somewhere around here. Okay, if you plug in 5 pi over 4, you're going to get out 5.4. If you plug in 4 pi over 3, you're going to get 5. If you plug in 3 pi over 2, cosine of 3 pi over 2 is 0, and 4 minus 0 is 4. Okay, and then when you plug in 5 pi over 3, cosine of 5 pi over 3 is 1/2 times 2 is 1, 4 minus 1 is 3. All right, and then we'll see symmetry from the beginning. So if you plug in 7 pi over 4, you're going to get out approximately 2.6. And if you plug in 11 pi over 6, you're going to get approximately 2.3. And then back to 2. So it's just kind of like a little bit flattened, if you will, on the right-hand side there. We call this a convex limacon. And I'll come back with a second video on our other figures.